In our final section of Chapter 8, we want to work on factoring polynomials completely. So again, our learning objectives are to take all the things we've learned to factor polynomials. And we're going to learn a new one, factoring by grouping. And factoring completely is just that. It's factoring it until it can't be factored anymore. So we're just breaking it into its smallest possible multiplied parts. So one thing that can happen when we're working with grouping is basically taking the concept of the distributive property and using it, I like to say, backwards in order to factor. And what happens is midway through grouping, it looks like this, where you can see I have 6z times z minus 4 minus 7 times z minus 4. And what that becomes is it becomes 6z minus 7 times z minus 4. Okay, and all I really did is I used the distributive property. See, these items are going to make these items here. And I used the distributive property to unmultiply something. We're used to this. I know that I have to have a times both of these items, and I have to have b times both of these items. And we normally do one at a time. I do a times c and a times d and b times c and b times d. But if we think of it just as an initial step, the first thing I'd have is I'd have a times both of those items. And then I'd have b times both of those items. And then I would go ahead and continue to multiply out AC plus AD plus BC plus BD. And this is how the distributive property tells me to multiply this out. And you'll see that this step right here is the same as that. Okay, and that's what we're doing is we're going to take items that look like this, and we're going to factor them back to look like that, so that we can finish factoring them to be two binomials. Okay, so let's look at how that's going to happen. So the reason it's called grouping is I've got these four terms, and I'm going to break them into two groups, because if I look at it, I go, well, there's no monomial term I can factor out of all four terms. So then let's look at the two items, the two halves of this polynomial, and see if there's something I can do with those. So if you look at just z cubed minus 4z squared, I can factor a z squared out of that. So now when I look at the smaller portion of the polynomial, I can factor a monomial term out. And here with 3z and 12, I could factor a 3 out. And then I'll have z minus 4. And when this binomial and that binomial are the same, and they are here, they're both z minus 4, I can proceed to take z squared. Right? I'm going to take z squared. I'm going to take the operation sign plus, and I'm going to take the 3. And they become this binomial times z minus 4. Okay? Now, because I have a quadratic function here, I'd still look to see if I can factor it. I can't factor z squared plus 3. I can't do that. So this is now factored completely. That's my answer. Okay, another example, I'm going to do the same thing. I can't factor a monomial out of all four terms, but I can now look at these as two separate groups. Now what's complicated is that when I look at this one as a group, you'll see because of this minus sign, I'm going to have to account for that. And there are two different ways I could look at that. The first binomial, I can factor an a squared out of that. This is a squared times a plus 13. Now here, when I put parentheses on, I could look at it that what I'm really doing is I'm going to say minus 5a plus 65 by putting parentheses on when I start to consider the group. Okay, and I could see that I can factor a 5 out of the 5a and the 65. So the minus sign is going to come down. I'm going to take the 5, and I'm going to have a plus 13. Equally, you could have just thought of it that you factored a negative 5 out of negative 5a and negative 65, and you get the same thing. Okay, either way you want to look at it. And this then becomes a squared minus 5 times a plus 13. Okay, and that is fully factored. Again, I certainly want to look at this quadratic function, a squared minus 5, to see if it's factorable. That's a perfect square, but this is not. So it doesn't fit one of the special patterns, and this is not something I'm going to be able to factor. Okay, so this is how you factor by grouping. You're splitting a 4-term polynomial into 2 groups, and then you're factoring a monomial out of each group, looking to see, once you've factored that monomial out, does it leave the same binomial, and in this case it certainly did. Okay, so when we talk about factoring completely, we've learned a lot of different things. First thing we always want to do is see, can we factor out the greatest monomial factor? Can we factor a monomial factor out? Then we want to look to see, does it fit one of these special patterns, difference of 2 squares or a perfect square trinomial? Because these are things that are easy to do. They don't require a lot of thought. They just require identifying something. If we can't do those, then we're going to want to continue on to factoring by comparing how our firsts and lasts might create a set of outsides and insides that will make this middle term, or what we would traditionally just call factoring a polynomial. And the last thing we might want to try, if I've got 4 terms, is I might want to try grouping. So you're probably going to want to work with these in this order, because the top item is the easiest and the bottom is the most complicated, and you want to try to find the easiest solution if you can. So let's factor something. All right, when I take a look at this, I can see there's a monomial factor I can take out of this. I could take 3 out of each of these items, and I can also take an n cubed out of each of these items. 3n cubed. And what that leaves over here is n squared minus 16. Okay, now I can see that this is a perfect square and that's a perfect square. So this is the difference of 2 squares. This is n plus 4 times n minus 4. And now I've got everything broken down and I have factored it completely. This is done. Okay? If I wanted to go on and find the solutions, this is a 5th degree polynomial. I should find solutions. There are 3 solutions here, 1, 2, 3. They're all 0, 0, 0, and 0. It's a repeated solution. The solution of this is negative 4. Right? Remembering that I'm looking to see what will make each of the n's create something that equals 0. So I had 3 of those. N is equal to 0, n is equal to 0, n is equal to 0. I have n plus 4. If I set that to be equal to 0, I get n is equal to negative 4. And if I have n minus 4 set to 0, I get n is equal to 4 as a solution. So these are all 5 solutions. And you'll see that when I factored it down, I have 1 solution for each of the variables, n. Okay, there were 3 of them here that all created 0. All right. Here's a 4-term polynomial. You'll notice that it's bigger than the quadratics we've been working with. The first thing I want to look at is, can I factor something out of all of the terms? No, I can't factor a monomial out of all the terms, so I'm going to split us into 2 groups. Remembering that when I put parentheses on after a minus sign, I have to change the signs because we're distributing the negative 1, right? So negative 25h becomes 25h, and negative 100 becomes positive 100. And then I want to look at the 2 groups. I can factor an h squared out of this group, and I get h plus 4. I can factor a 25 out of this group, and I also get h plus 4. These two items are the same, so I can proceed with my factoring. It has indeed met the criteria for factoring by grouping. And now I have the difference of two squares. H squared is a perfect squared and 25 is a perfect square. So as I continue to factor, this is going to be h minus 5 times h plus 5 times h plus 4. Again, if we talk about solutions, 5 minus 5 equals 0, negative 5 plus 5 equals 0, and negative 4 plus 4 equals 0. So these would be my solutions. Okay? They didn't ask me to solve. I just figure normally we're factoring so that we can solve things. We might as well talk about that now. Oh, look, solve a polynomial equation. There they go. Okay, so again, I've got 4 terms. I want to see even number, odd number, so I can't factor a 2 out of everything. I can have a y, but no y here. I can't factor the variable out of everything. So since I can't factor a monomial out and I've got 4 terms, I'm going to look at factoring by grouping again. So I'm going to create my groups. Again, it's after a minus sign, so the signs are going to change. Negative 16y becomes plus 16y, and plus 28 becomes minus 28. And now I want to try to factor something out of this. I can factor a y squared out of this. So that becomes 4y minus 7. And then I can factor a 4 out of these. That becomes also 4y minus 7. So again, these are the same. So it meets my criteria. I'll have y squared minus 4 times 4y minus 7. And again, y squared is a perfect square, 4 is a perfect square. This is y plus 2 times y minus 2 times 4y minus 7. And if I want to find the solutions, negative 2, 2, and in this case, if I've made 4y minus 7 equal to 0, I'm going to add 7 and divide by 4, so I'll have 7/4. Okay, these are all of my solutions. Third degree polynomial, 3 solutions. I've certainly found them all. Okay, and one final example. We have a terrarium here, and they've given me some dimensions for this terrarium. It's the shape of a rectangular prism, and it has a volume of 4,608 cubic inches. Its length is more than 10 inches. Okay, so I know that L is greater than 10. The dimensions of the terrarium are shown. Find the length, width, and height. Okay. Length, width, and height. So if I wanted to look at it, I know that the volume, I want to make a verbal model. The volume is equal to the length times the width times the height. So this wasn't totally a verbal model. I'm sort of partially in the math world, but I didn't want to write all the words out. So if I want to then write an equation, I know that my volume is 4,608. I have my length, 36 minus w, times my width, which is w, times my height, which is w, plus 4. And that's my equation. If I want to go ahead and solve the equation, I'm going to need to multiply it all out. So I'm going to begin by multiplying the binomial, right? So I know I'm going to have 36w. So I'm multiplying this times that. This w is going to be out here. (36 times w gives me 36w. 36 times 4 is 120 plus 24, so that's going to be 144. And I have minus w times w, that's minus w squared. And minus w times 4 is minus 4w. And when I combine like terms, in fact, what I'm going to do here is I'm going to take these items and I'm going to put them on the next page. Okay, so if we add a page, I'm going to put those there because we're just going to run out of room here and it's going to become a mess. Okay, so when I continue on, I'll have 4608 is equal to, I'm going to put this in the correct order, by the way, as well. So I'll have negative w squared. I have 36 minus 4, so that's going to be 32w. 32w plus 144. Okay, and then if we distribute the w into everything, we're going to get minus w cubed plus 32w squared plus 144w is equal to 4608. Now, if I want to solve this polynomial, I need to make it equal to 0. And I don't want a leading coefficient that's negative, so I'm going to move all of these to the other side. So I add w cubed, I subtract 32w squared, I subtract 144w, and we had the 4608. And now it all equals 0. Okay, great. Now I can proceed because now I've finally got the equation. Okay, so I'm going to copy this and I'm going to bring it on to the next page. Right, here we go. Now I've got 4 terms. I want to see first, can I factor a monomial out of everything? No, I really can't. So I'm going to split these into groups, and I'm also going to factor it. So I can factor a w squared out of that, minus 32. And now I'm going to subtract, and that's going to change the sign. So this is going to become a minus sign. And one thing that can help you is, remember, I can only continue factoring if this binomial over here ends up being w minus 32. So I would have to factor a 144 out in order to get w. So then I want to double check, and I'm going to pull out my handy dandy calculator. Is 4608 divided by 144 equal to 32? And yes, it is. Okay, so what's helpful about this is I know that if I'm factoring something out of this second pair, the second group in this polynomial, the only way it helps me is if what I'm factoring out is this w minus 32. Okay, so it helps me to know what I'm supposed to do. So if I have w squared minus 144 times w minus 32, and then I want to make these, this is a perfect square, that's a perfect square, so I'm going to make these conjugates. And then we look at the different possible values of w. So it could be negative 12, it can be positive 12, and it can be positive 32. So now let's go back and look at what's the possible solution based on the information we had. So I have negative 12. Now that can't work, right? It's not going to work because negative 12 is not going to work because I can't have a distance that's negative. There's no way for me to have a width that's negative 12 inches. 32 inches isn't going to work because when I take 36 minus 32, it violates this rule that the length is more than 10 inches. Okay, so 32 is out. That means my length must be equal to 12. Okay, so 12 is the correct solution. Okay, so then if we want to find the height was w plus 4. Okay, so if I have 12 plus 4, h is equal to 16. If I wanted to check my work, I know that I would have these dimensions, which is 36 minus 12, right, which would be 24 by 12 by 16, and I could multiply those all out to see if they make 4608 to check my work. Okay, and that's finishing up our lessons on factoring polynomials by learning about grouping.